Hi there, this is your favorite non-Indian math channel, and let's see how can we find this definite integral. And well, we will solve it by the famous Feynman's method. And what he does is like he tries to define a function, okay, that is similar to this one from 0 to 1, and then we will differentiate this thing with respect to a, and we will try to get something simpler. Okay, so if I actually make this x to the a instead, this seems like we are generalizing the problem. Okay, uh, so but if I now differentiate this thing with respect to a, and Feynman says we can do, so let's write it how we can do it. So uh, So I'm differentiating this side by with respect to a, okay? So right side is d over dA of this integral, okay? X to the a minus 1 divided by ln x. And this is the important part, like the theorem part that says this is equal to d over dA, d over dA, x to the a minus 1 over ln x dx. So if we differentiate this thing with respect to a, we will get, if I differentiate x to the a with respect to a, I will get ln x times x to the a. So it will be ln x times x to the a. And this is why we are doing this thing, like to get rid of this ln x at the bottom, okay, dx. So this is equal to, from 0 to 1, x to the a dx. So a is just like a constant. Here we can integrate with respect to x. So this, by the power rule, it will be x to the a plus 1 over a plus 1. And bounds are from 0 to 1. So this is going to be equal to, I just put 1, and when I put 0, it will be 0. So it will be just 1 over a plus 1. So I can write this thing like the derivative. So this was I prime of a, okay? So I took derivative of I, and I took this thing. And now my goal was to find I of a, and actually I should, if I evaluate this I of a at x, a is equal to 5, okay? If I say if a is equal to 5, then I of a will be equal to my integral. Let's call this I, okay? It will be equal to I. So my integral is I of 5, okay? Let's write it nicer, I of 5. So let's see how can we find I of a. So if I integrate both sides, this is ln a plus 1 plus c. The problem is plus c now, because if I just put 5, I will have this is equal to ln 6, but I also have plus c. So let's see how can we find this plus c. Is there any value that I know any I of a? Okay, so let's think about this. So if I can make this thing 0, which is if I put a is equal to 0, okay, this top part will be equal to 0, and this is ln x, so this integral is going to be 0. So from here I know that I of 0 is equal to 0. So now let's go back here, and if I put a is equal to 0, I know that this left side is 0. So ln of a plus 1, so this is just ln1, which is also 0, plus c. So since this is also 0, then this says us that c is equal to 0. So now I'm done. I know that I of a is equal to ln of I plus 1. So I solved this integral for any value of a, okay? So now I can just substitute a is equal to 5, like I said. So I of 5 is going to be my answer, which is ln of 6. And that's the answer. Also a note about convergence of this integral. Well, I pretended like this is convergent for any a, and actually from the Feynman's method we can't say anything about convergence of this integral. So we need to consider it separately. Okay. So for this integral, let's show that this is convergent for a is greater than 0. Okay. This is not the best range that this is convergent, but let's show it for a greater than 0. Okay. So on this interval we will check both of these limits, okay, as x as a limit as x goes to 0 from right side, because we are on the interval of 0 and 1. Okay, so I'm just taking this limit, okay, x to the a minus 1 over ln x. So this will be 0, which is, so when I put x is equal to 0, this bottom will go to minus infinity, and this will be minus 1, so it will be 0. Okay, so this limit will go to 0. I can say that directly. Okay, so this will go to 0. And for the upper limit as x goes to 1, from left side, x to the a minus 1 over ln x. This is a bit more problematic because uh, if I put x is equal to 1, this will be 0 over 0. And now, yeah, there's an indeterminate situation here. Okay, so this is 0 over 0. So I can use L'Hopital, and I can say limit as x goes to 1 from left. So I'm just taking derivative of this top side. It will be a is just a constant, a times x to the a minus 1 by the power rule over if I take derivative of ln x, it will be 1 over x. So I can throw this x on the top side. Okay, so this will be limit as x goes to 1 from left. So it will be x times a to the minus 1 times x, so it will be a times x to the a. And if I put x is equal to 1, this will be just a. So what this says me that there is no problem on the left side because this limit goes to 0. So let's graph this function more or less. Okay, so I know that if I put x is equal to on this interval between 0 and 1, ln x is negative, and x to the a minus 1, this will also be negative because x to the a is like between 0 and 1. So as x goes to 0, this limit is 0. Okay, so this function goes to 0. And when I go to 1, so all of these values are positive because it's negative over negative. Well, this won't be a detailed graphing, so it's just to see what's going on. And as x goes to 1 from left side, this limit is equal to a. Okay, so it's going like, let's say this is the point 1. This is going to a. Okay, this limit is approaching to a value, and this is bounded. Okay, so I can of course say that this limit is convergent. Okay, so this is not an improper integral. Also, a fun fact that I discovered, when a is greater than 1, I have this inequality, a to the x minus 1 over ln x is less or equal than, it's actually less than a times cosine of x minus 1. I was just playing with inequalities and I discovered this. This is also a way to show that if I take integrals of both sides, okay, so this is greater than 0 because it's, as I said, it's negative over negative. And if I take integral, if I integrate both sides from 0 to 1, I can say that this is just, it will be just minus a times sine of x minus 1. Sorry, it will be plus. And if I just put the boundaries, it will be, if I put 1, it will be equal to 0. If I put 0, it will be minus a sine 1. So it will be minus minus, it will be plus a times sine of 1. Which means that this integral is less than a times sine of 1. And if you remember, I found this integral being equal to ln of a plus 1. Okay, on this interval it's positive, so I can say it's ln a plus 1. And let's see about this inequality. So as I said, this limit when a is greater than 1, it's less than a times cosine of x minus 1. Okay, so if I increase this a from 1, this red line is always below the right one on this point 1. This is the interception point. And also I found the left integral being equal to ln a plus 1, and right integral is a times sine of 1. So if I look, this value is negative, so which means that this left thing is less than right thing. And if I just wiggle on this bound, okay, from a, this all of these values are negative if you look at these values. So this also shows that we found a successful bound. Okay, so this integral is also less than a times sine of 1. And yeah, that's the end of it.